Hello everyone. In the previous session we discussed about data structure, types of data structure, kind of definition, characteristics of data structure, as well as operation can perform on data structure. So today we are discussing about primitive data structure. So primitive data structure is a type of a data structure. It is first we observe the definition for the primitive data structure. The primitive data structures that are directly operated upon by machine level instruction instructions are known as primitive data structure. Okay, definition for this here. So the primitive data structure that is directly operated upon by a machine level instructions. So what do you mean by machine level instruction? So machine level instruction basically we known as a low level language, that is machine level language. This is the only language machine can able to understand. Okay, the machine what we are giving in a high level languages such as C, C++, Java, whatever the language you consider, you write a program, it has to be translated or converted into low level language. So then only computer can able to understand. So here the machine level we are operating upon by machine level instruction directly. Okay, so machine level language means it's a binary digits or binary digits or values, that is 0 and 1. Okay, 0 and 1, otherwise also called off and on. Okay, so this is the only language machine can able to understand. We are directly operated upon by machine level instruction are known as primitive data structure. And one more thing, primitive data structure is the most fundamental data type, usable in the programming language. Okay, so it is the most fundamental data type usable in the programming languages. Next is that, so basically as I discussed in the previous session, we have 5 types of primitive data structure, that is integer, float, character, double and pointer. Okay, these are all the types of primitive data structure. Suppose you can ask the question, why do we need this primitive data structure? Will be serves as the foundation for data manipulation. Okay, so the primitive data structure, it is used for in a programming languages that will be serves as the foundation for the data manipulation in a programming language. Okay, so the next is that it is also known as basic data structure, also known as basic data structure or the building blocks or the building blocks of any program. Suppose you are implementing up any languages in a program, so the primitive data structures are the building blocks. So why do we need that primitive data structure? First, this data type serves as the foundation for data manipulation in a programming language. A second thing, it is also known as a basic data structure. These are all the building blocks of any program. So these are the reasons to we are using the primitive data structure. The data manipulation is nothing but, suppose I has to represent a numbers, suppose I has to represent a characters or boolean values. So while representing those characters or those numbers, those any boolean values, in that situation we are utilizing the primitive data structure. They are easy to represent in a simple way. Okay, this is the reason we are using the or needed the primitive data structure. So next we will move on to the characteristics of primitive data structures. Characteristics of primitive data structure. Okay, so there are several characteristics make them different from the complex data structure, that are such as an array, linked list. So while compared to the non-primitive data structure, it will be with the several characteristics. Okay, so first I have to list out first. So first characteristics is a built-in, simple, next is a fixed size, next storage in memory. Yeah, I am listing a few characteristics here. The first characteristics here, that is built-in. So built-in means this are all the predefined in a programming language, predefined in a programming language. Means the primitive data structure is provided by programming language itself, so there is no need to define or import them from the external library. So these are all called as a built-in data types. So next we'll move on to the simple. So the primitive data structure are simple to use with a straightforward operation, with a straightforward operation, such as assignment operation, comparison, and arithmetic. So take an example. So here I should ask to assign the value 5 to the variable a, that is int data type. Next I am mentioning the variable, I am assigning the value, put a semicolon. So this is the way of creating a integer data type or assigning a value to the integer data type in a C language. Here variable means, so use that word, that is variable. Variable means it's the name of memory location, name of memory location, store that we location that we use for storing data. Okay, variable means the name of the memory location that used for storing the data. So here I am assigning the value 5 to the variable a. It's a easy way to assign the value to the variable, assigning to value to variables. Okay, so while taking a comparison is nothing but it's a 5 equals to 5. Is it right? It will be either true or else false. If not, 5 is not equal to the, say suppose 5 equal to 6, is it right? 5 and 6 is not equal, then at that moment it has to be give the value that is false. Okay, this is the comparison. So these are all we are directly, I mean it's a straightforward operation we can perform. So that is the one way to say that it's a simple or simple to use. Next we'll move on to the fixed size. Okay, so what is fixed size? Take an example here, int. So int basically in a C language it will be occupy the 4 bytes of memory. Okay, it will be the 4 bytes of memory. Here the 4 byte means it is the storage of the particular data type or size of the data type. It can able to store up to 4 bytes. Okay, the fixed size, it is determined by the programming language, determined by the programming language. Okay, it is determined by the programming language and system architecture. Okay, so that will be depending on the programming language. In a C language it has to containing 4 bytes. So and one more thing, the fixed size is here int have a 4 bytes, we cannot resize that data type. Okay, we cannot resize it once they have been created. So this is the fixed size. So next we will move on to the storage in a memory. The primitive data structure are stored in a memory, stored in a memory. Okay, it may be typically in the stack or heap. So depending on the language, depending on the language and the way they are created. So these are the few characteristics of a primitive data structure. Okay, so it is a built-in data type, it is a simple to use, it has a fixed size and storage in a memory. Okay, so next we will move on to the types of primitive data structure. Types of primitive data structure. So as I mentioned, basically we have the 5 types, that is integer, float, character, double, pointer. We discuss one by one. Okay, so the first is a integer. What is integer data type? That is, it can able to store, use it to store numbers. Okay, use it to store the numbers. What is the condition? That is, the numbers do not have decimal or fractional numbers. Okay, so basically integer data type used in a to stores the numbers. What is the condition? That the condition here, it does not containing any decimal or fractional numbers. So well, come to the mathematical concept. So the integer is a range between minus infinity to plus infinity. Okay, well, comes to the mathematical concepts. Okay, here is also integer can able to store the including negative numbers as well as the positive numbers along with the 0. So in another words, you can define that it can able to store whole numbers numbers including both positive and negative numbers. Okay, so this is the integer data type a definition. Okay, so basically it have three types in an integer. One is short integer, long integer and int. Okay, so that is short, int and long. Okay, so these are the keywords. Here I should mention integer can be implemented in a programming language as int. Okay, it's a keyword. Keyword means the meaning of this word already defined in the programming language itself. There is no need to define that word a meaning in a while implementing any kind of programs. Okay, that is keywords. We also known as a reserved words. The meaning of that particular words already defined. The computer understand that while write that word. Okay, so short int have 2 bytes, int have 4 bytes, long have 8 bytes. Okay, so bytes is nothing but it's a collection of byte. What is byte? Supposed to ask a question. Byte is a collection of 8 bits. Okay, so bit, what is bit? Bit is nothing but either 0 or 1. Okay, either 0 or 1. What is 8 bit means? Suppose that is it's a combination of 1 and zeros, that is 1 0 1 0 1 0 0. So this is the collection of 8 bits. What is bit? Bit is nothing but each value, binary value. Okay, this basically we known as a binary digits. Is that right? So that is each value we known as a bit. The collection of 8 bits we known as a byte. Okay, so here representing the memory. Okay, size of the memory, how it will be allocating. Okay, int have 4 bytes and long have 8 bytes. What is the drawback of integer data type? It can only able to store the number, does not contain a decimal or fractional numbers. Okay, so to overcome this drawbacks, we have another data type, that is float. Float data type. The float data type means the number, it will be stores the number. The float data type means it is used to store the numbers. It is used to store the numbers. Thus it can contain fractional or decimal number. Okay, what is the drawback of the integer? It can unable to store the fractional number. In a float data type, it is used to store the numbers. Maybe it can contain a fractional or decimal numbers. Okay, so here the float data type have 4 bytes. Okay, so basically a float data type we are used to store the mantissa. Mantissa means that is significant digits. Okay, so this is basically used to represent mantissa. Mantissa means the significant digit. Okay, and next is that it is also used to store therefore exponent. Exponent means the power of 10. And the float is used to represent single precision floating point format. Okay, so suppose I consider like example, so that is example we can create, that is float b is equal to 3.1412 etc. Okay, so this is the float data type. So here what is the drawback of the float data type? It can able to store a few decimal numbers. It can unable to store the large decimal numbers. Suppose consider an example. While considering here, it can able to store after the decimal, it can contain maybe store up to 10 numbers. Okay, so in scenario is after the decimal it containing 12 numbers, decimal numbers, it has to be stored for future action. Okay, the each decimal number plays a vital role to take towards the results. So in that moment we are using the another data type, that is double. Double data type. Okay, so what is double data type? Double data type is also used to store the fractional values or fractional numbers. Or decimal numbers. Size of the double data type is 8 bytes. Okay, what is the size of the float data type? It is only 4 bytes, but size of the double data type, it is an 8 bytes. It can able to store a large decimal numbers. Okay, so it is used, and one more thing, it is used to store high precision floating format. High precision floating point formats. Okay, take an example, that is double. Okay, b is equal to 3.1412167891023456 etc. Okay, what I am mentioning like example double and given assigning a value, it's also known as it's a syntax, the way of creating the data types. Okay, so here I am considering float data type. It is a way of creating the float data type. It is use the syntax. It is a syntax. Syntax is nothing but a set of rules. Okay, how we are able to create, what is the process or what is the rules we has to create, follow to create the variables. Okay, in a float data type, in a double data type. Okay, so this is the double data type. So you can also raise a question that So we are mentioning that we are only used to these data types to numbers. So suppose I has to store the character also. So what to do in that moment? So that's why we have another data type, that is character data type. Character data type are used to, or it is allows to store the individual characters. It is represents the single character. What is single character representation? Means what is individual character? It may be a both uppercase or a lower case letters. It may be a digits, that is 0 to 9. It may be a punctuation mark, or space, or any other symbols, and any other symbols to represent. Okay, so it is in the form of ASCII format. ASCII means it is one of the computer code. It's an internal representation of the computer system. ASCII acronym is that is American Standard Code for Information Interchange. Okay, so this is the character or data type. Here the character data type size is 1 byte, because it has to individual characters and it only represents the single characters. So it can able to represent, so that is with the help of the single quote. Okay, use it to represent with the help of the single quote. Suppose I has to represent A, that will be with the help of the this single quote. Okay, so that is character. Take an example, character, next variable is equal to A. Okay, so this is the way of creating a character data type. Okay, so next we will move on to the another data type, that is pointer. So pointer data type, it is a derived data type. Okay, it is a derived data type. Derived data type. So basically derived here, that is aggregation of the fundamental data type. Okay, aggregation of the fundamental data types. Okay, so basically it is a concept of extension or modification. What are the drawbacks of the earlier thing, that will be overcome the drawbacks or modify the thing, then will be generate the a new thing. Okay, so that is basically we known as a derived. So it is a derived data type. Okay, so pointer is that it is used to store the address of the memory. It is used to store the memory address of the other variable or location. So syntax for this one, take an example, that is int data type, and one more thing, while accessing the pointer data type with the help of the asterisk symbol, basically we known as a star. Okay, PTR, the star indication, that is pointer data type. Okay, so this is the pointer data type, and size of the pointer data type, it will be depends on the system. Okay, the size of pointer data type depends on the system architecture. if it is a 32-bit system, then a pointer uses 4 bytes. Okay. Or if the system is a 64-bit system architecture, then a pointer occupies 8 bytes. Okay. So it will be varying based on the system architecture. If it is a 32-bit system architecture, it will be occupied the 4 bytes. If it is a 64-bit system architecture, then it will be occupies the 8 bytes. Okay, these are all the primitive data structure, the definition, and as well as I give the syntax for those things as I mentioned in an example. Those are all the syntax for the particular data types. Okay, thank you.